Awesome.
Single out salute. I'm Lord Maitreya, the hip hop futurist. You're now tuned into the Super Longevity Institute podcast. Today, I have a special guest. He is a researcher, science debater, futurist, transhumanist, and author. He holds a PhD in computational neuroscience from Stockholm University and is currently a senior research fellow at the Future of Humanity Institute at the University of Oxford. His research centers on societal and ethical issues surrounding human enhancement and new technology, as well as on assessing the capabilities and underlying science of future technologies. His research includes work on cognitive enhancement, methods impacts, and policy analysis, a technical roadmap on whole brain emulation, on neuroethics, and on global catastrophic risk. Ladies and gentlemen, hip hop futurist transhumanist worldwide, Dr. Anders Sandberg. Welcome to the Institute. It's a pleasure to have you on.
Thank you. It's delightful to be here.
Oh wow. Where do I begin, man? How did you find transhumanists? Like, tell us a little bit more about your background. How did you become a transhumanist, a futurist, and how did you become interested in the career path the career fields you chosen?
Uh, so, as you might hear from my accent, I'm from Sweden, and I grew up actually right here in this very apartment I'm sitting right now.
Mm.
And it's in Hagalund, a northern suburb of Stockholm, with a bit of a tough reputation, actually.
Wow.
It's even been called a slum by Swedish politicians, but
Wow.
I like it here. But
Wow.
it's very boring. So imagine 1970s suburbs of Stockholm. I was, of course, reading all the science fiction novels I could find at the local branch library.
Mm.
And then one day, as I was doodling and trying to construct a spacecraft, I realized I have no idea if this could fly. How do you even tell if a spacecraft could fly? Maybe there's some science stuff in that. So I started reading the science books, and I never stopped. I went to the municipal library once I was done with the branch library, and then the Stockholm main library, and then it's the university libraries. And well, now I'm writing my own book because unfortunately, the stuff I want isn't in the books. So I
Mm.
wanted to kind of get out there, get to the future. And well, then the question is, what is a good future? What's a bad future? What's an exciting future? And how do we bend the world so we end up there?
Mm.
So that's my career path.
Wow. When okay. Can you tell me uh what can you give me what is the mission statement for the Future Humanity Institute that you're a part of? Because I know Nick
So
Bostrom is there also over there. I have one of his books, Global Catastrophic Risk. Actually, I have that on my desk. Right?
yeah,
Scary
it's
book.
an awesome book full of horrible, horrible stuff, but it's a very good book.
Yes.
And the story is basically that our remit at the Institute is to think about the very long term future. Think about literally fate of the world question and try to figure out how do we make sure humanity gets a happy ending, whatever that
Mm.
means. And that means, of course, thinking both deeply about risks and possibilities, but also thinking about the thinking itself. How do we even say something sensible about the future? After all, most prognostication and most forecasts and most prophecies don't work out that well. Can we do something useful?
Mm.
So that's really what we're all about, trying to make sure that the future gets as good as it's possible.
Wow. I want to give a shout out to everybody at the Future of Humanity Institute. Thank you for all your great work. I think you need more publicity. More people need to know about your great work and what you're doing and providing for humanity is extremely important. Um, can you tell me what's the difference between an accidental risk and a catastrophic risk for those hip hoppers out there who might not know about this subject and is new and just tuning in now?
So when we talk about risks, there is something bad that happens. And we can, of course, discuss how likely it is that it happens, but also how severe the badness is. So you can imagine, of course, a personal catastrophe. Somebody runs sick, or you'll get very sick, or you might die. But then there are the local disasters. Something might happen to a city. You could even imagine a global disaster, something very bad, like let's say a pandemic that affects a lot of people and crashes the economy and makes life no fun. But you can survive it. Many people might be harmed by it, but it's still bad. You can even imagine a really serious global disaster that might affect us, and all the history books will always talk about. But then there are the existential threats to humanity. They are the ones that you don't get back from. Either, either you're extinct or you wish you were extinct.
Oh,
And that's kind of the end of the story. So they are amazingly bad.
wow. Well, thank you for that. Wow, it's very scary stuff.
Yeah, and it's interesting because we like some of the disasters because they make for good disaster movies. An
Yeah.
asteroid impact, it's kind of a small one. Oh, that's just a lot of local drama and fireworks. And certainly we can survive many of the smaller asteroid impact.
Uh,
Pandemics, less fun, but you can still make a good zombie movie or something like that. Um, Full-scale nuclear war, at this point, things start getting a bit dodgy for the prospects of humanity. And we can imagine worse things, especially since technology gets getting more powerful. So Mother Nature might cause some risks, but we humans are very good at adding to that list of stuff that can go wrong. And that's, of course, both good news and bad news. It's bad news because it's us humans causing this. But the good news is, oh, we're causing it. We can actually also stop causing it or do something about
it's funny you should say that because when I was the first time I ever came in contact with knowing about accidental risk is as a child, like 2 years old. I think my father gave me a book on dinosaurs, and I just kept reading. I said, Pop, how did the dinosaurs get taken out? They really got taken out by an asteroid? I just couldn't believe it. That's the
it.
first. I was 2 or 3 years old. I was like, dude, this is crazy. An asteroid hit the Earth and the impact destroyed, took out a whole species. I was just, it just, I never got that out of my mind since an adult. Just constantly always thought about how fragile life was. Do you think that what are scientists doing in order to because this idea that an asteroid can hit us and just take out humanity and everybody on it, um, it's something that we got to work to prevent worldwide. Everybody in the world has, all the governments have to get together to work together to fight and make to prevent this situation. What are scientists doing to help deflect the asteroid? What are some of the things they can do?
Well, the nice thing about asteroids is that it's the kind of threat we have a decent handle on. And at this point, of course, my colleagues in the planetary protection community, as it's called, are going to look, wait a minute, we know we don't know so much. But I would say, in comparison to some of the other risks, oh, yes, you're doing fine.
Mm.
So the classic thing that makes for good movies is, of course, send up nuclear weapons and try to blow up the asteroid. That doesn't work so well, it turns out, because most asteroids are like not so much rocks as big piles of gravel. So if you just nuke them, you get a radioactive pile of gravel instead. Not so fun. What you
Mm.
can do, though, is to push it. And if you do this early enough, you can get it off course so it misses Earth. Now,
Mm.
nuclear weapons are not the best way of doing that. Probably what you want to do is send a rocket, put the rocket on the asteroid, fire the engine, and kind of push it sideways. And it doesn't even have to be a very strong rocket. In fact, weaker rockets are better because they can keep on pushing for a longer time. So people have been talking about stuff like gravity tractors, which are essentially fridge-shaped little satellite hanging out next to the asteroid, pulling them using very weak engines and their own gravity, slightly off course.
Mm.
Even modern attempts have been based on the idea that if you paint one side of asteroid white, it actually reflects sunlight, and that affects its orbit. And it's very weird, but actually heating from the sun changes asteroid orbits. And if you just know well enough in advance that that asteroid is going to be trouble, um, you can paint it white and then wait long enough. So when I went to the big planetary protection conference, you had the mild people talking to the mathematicians plotting orbits, kind of planning many years in advance. Let's throw some paint at it. And next to them were the gravity tractor people. And then you had the people saying, lasers, lasers. And the scary people on the other side saying, well, thermonuclear plasma is not the solution to every problem in life, but we have it if you need it. The real problem is we need to see it coming. We need to actually notice that an asteroid is in a bad orbit. And this is the tricky part, because, of course, a lot of asteroids are small and they're quite dark. Many of them are basically dirty snow piles mixed up with gravel. And when the snow on the surface evaporates under sunlight, quite often many comets are just like that, but eventually they get covered by this dark crust. And at that point, they're just sitting there orbiting, and sooner or later they might run into a planet. The really scary ones might, however, be fresh comets coming in from really far out in the solar system, because they're surprises and they're really fast. So this is why we need a lot of satellites. This is why we need to kind of watch the skies in the right way. And the good news is some of these satellites up there are doing an amazing job. At that particular conference, I was sitting next to a lady who had discovered 200,000 asteroids with her satellite.
Wow.
200,000.
That's incredible.
Yeah. And most of them are, of course, totally benign. They're orbiting around in the asteroid belt or elsewhere. Very few of them cross Earth's orbit. And even those who do, many of them are pretty small. And if they were just to hit the Earth, it would be some nice fireworks, but that's it. But occasionally get a bigger one, like the one that hit Russia in Chelyabinsk a few years back, that blows up and crushes the windshields and the windows all around the place. Or even more rarely, even bigger ones, like the one that hit Russia again in Tunguska in the early part of the 20th century, which made a pretty big crater. And had that happened somewhere else, well, it would have flattened the city.
Whoa. My gosh.
Yeah. And they're still not even dinosaur killers. They are fortunately really rare. They only hit us every maybe 10 to 100 million years, those really big ones.
Wow. Thank you for explaining that. Wow. Let me see.
Yeah, I find asteroids amazing. They're kind of so neat because they're so concrete. Indeed, there are a lot of asteroid impact craters around here in Sweden, simply because the surface of Earth is fairly old here. So in many parts of the world, you have exciting geology, which of course causes other risks like earthquakes, volcanoes, and tsunamis. But the end result is that the craters kind of get wiped off. So around here, you get very boring old rocks, but you get the craters that stay around for a long time. I think about that sometimes when I look out of the window from my husband's apartment, because at the horizon, I can see a dip, and that's the Loch Ness crater. 485 million years ago, there was a very bad week in that vicinity when an asteroid hit the shallow ocean. And well, this was long before the dinosaurs were around. Only a lot of fishes got hurt, but whoa.
Wow. Have you ever heard of a pole shift? Did that ever happen with in the past? Did we ever have pole shifts?
Not really. Or rather, the magnetic poles of Earth, they flip from time to time. And this is sometimes mixed up with the idea that maybe Earth kind of flips around the entire planet.
Yeah.
That doesn't happen because of the law of angular conservation of angular momentum.
Okay.
Basically, things that move tend to move in the same direction as we used to. That's kind of what Newton's laws of mechanics. And this is true for rotating objects too. They have a fixed axis of rotation that only wobbles a little bit. So that is why Earth is not going to flip around that much, despite the forces from the moon and the sun. However, the magnetic poles do flip because they're caused by electric currents inside Earth's core. And there is a lot of weird stuff going on there because we're talking about molten metal at very high temperature that's rotating. And for some weird reason, every few tens of thousands of years, it flips the poles. That's going to play around with the compasses we got and probably lead to at least a century or so of slightly more background radiation. But we have survived it in the past. It's not a disaster. So usually people get worried about the wrong kind of disasters. For example, I've become way more scared about super volcanoes than recently.
Took that out of my mind. I just was going to say something about super volcano. Go ahead. I'm sorry. Yeah, go right ahead.
So the cool thing Yeah, the cool thing about supervolcanoes is we haven't known about them for more than a few decades. This is kind of a new discovery that, wait a minute, there are enormous amount of ash and dust, let's say, in the western part of the United States, and they all seem to have come from the same eruption.
Mm.
So everybody likes to bring up Yellowstone as the supervolcano, but actually it's a hot spot. There is an upwelling of really hot magma under the United States. In the North American plate is kind of moving on top of it. So you get
Mm.
this series of craters, and every few 100,000 years or million years, you get this enormous eruption, which covers a lot of Western America with ash. And if you're within 100 miles of that, oh dear, now you're going to get broiled. That's not very good.
Did this
Uh,
did this happen before in Indonesia? It happened in Indonesia before,
yeah,
right? Something to that
so that
magnitude.
was probably the closest call for us. So Mount Toba is right now just this big crater lake. But about 70,000 years ago, there was this enormous eruption and ash spread across much of Southeastern Asia. And of course, supervolcanoes affect climate, because you
Mm.
get an enormous amount of ash dimming the sunlight globally. Suddenly, temperatures go down, it doesn't rain. That's not very fun. And our ancestors might have been in dire straits here. There is some theories which are controversial, but there is some evidence that there was a genetic bottleneck back then, that the number of humans alive was very small. And that might have just been because of this enormous eruption. Maybe almost everybody died except for a few hundred people. And if we'd been slightly more unlucky, we wouldn't be talking.
Wow. Humans need to we need to come together. we, need to,
Yeah,
we need to come
at
together.
least we need to keep an eye on these really big volcanoes and
Yeah.
find a good way of storing up food and responding to it. And the good news is there are ways. I'm involved with an organization called AllFed that is doing research about how do we feed everybody no matter what. Uh,
Mm.
so Dave Denkenberger, who founded it, he wrote this amazing little booklet about this question. If you can't get sunlight enough for agriculture for 10 years, can we actually feed everyone? And the cool thing is there might be ways around it, because there is actually quite a lot of nutrients around, but in forms we normally can't eat. One example is wood. Uh, Wood is carbohydrates. In some sense, this is all sugar in my desk, in my chair, and in my pens. So if I could just break it down, I could get at least the energy from it. Of course, I need a good way of doing that, and maybe I need to mulch it and use mushrooms and fungi to do it, or you can do something chemical. There are interesting ideas about using natural gas to grow bacteria that you then can either use as fish feed or maybe even turn into some nutrient sludge.
Wow.
None of the proposals here sound particularly tasty, but if you're not getting any food, we're probably not going to be complaining anyway.
Yeah.
The cool thing about that idea is also this works against the sun being dimmed by dust from a big asteroid impact and quite a lot of other disasters. So many of the things we can do to reduce the risk for humanity are finding those common pathways that break something important for us and then trying to figure out, okay, how do we get around that?
Wow. Wow. Can you say the name of that organization that's trying to figure out how we
It's
can
called all fed,
oil fed, oil fed,
all fed,
oil fed?
feeding all.
Wow. I gotta look them up.
Yeah.
Wow.
Yeah, so we're trying to kind of demonstrate ways of doing this and thinking about other ways that nature or humanity could crash things. For example, we're pretty dependent on electricity. What
Mm,
if it was a giant solar flare that took out the power
yeah.
grid?
Yeah.
As we saw after Hurricane Sandy in New York, Wall Street, which after all is probably the richest part of Earth's surface, couldn't get a proper working transformer working for 2 weeks because
Wow.
money couldn't buy it. So they were without power way longer than the stock market would have liked. And that was just one small spot. Now imagine if there was this big solar flare wobbling Earth's magnetic field and burning out the transformers globally. That would be bad. So
Wow.
we might want to have a bit of backup plans in the case of that so we can rebuild without too much disaster.
Wow. I seen that and some of the lists that I came to I wrote about. What is a vacuum decay? I read about a vacuum decay. What is that about?
Oh yes. So I've been talking about disasters we know can happen. Asteroids hit us, and the solar flares have been big enough to wipe out parts of power grids. But this is a hypothetical one. This is physicists thinking about mathematics of quantum mechanics and kind of thinking maybe this is possible or maybe not.
Okay.
So basically, empty space is not that empty according to modern physics. It's full of quantum fields. In some sense, it has a fairly high energy density, which normally we don't notice because it's the same everywhere. It might be that we're seeing it as the mysterious dark energy that is making the universe expand, but it's very unclear what's going on. But that might mean that you could get a true vacuum. That is a vacuum that has lower energy than the vacuum we are seeing. If you got a little bubble of that, it would start expanding because the false vacuum around it would be pulling at it. So you would get this bubble of true vacuum expanding. Inside this vacuum, the rules of physics would be slightly different.
Mm.
Not super different, but different enough to wipe us out completely. And the really scary part about this story is that it would spread at the speed of light. So you wouldn't see it coming. It wouldn't be like you get some giant of the sky and you can say, oh Lord, what's going on? No, instead, it would just suddenly wipe out everything.
Wow.
So this is something you can use to scare young physicists with. It's kind of a very scary bedtime story in physics. And it's interesting because people get worried about these large particle accelerators. What if we could trigger vacuum decay by colliding particles at a high energy? And after a while, the physicists involved got a bit fed up with people asking this question. So they had to come up with an explanation. They pointed out, look, there are way more energetic particles out there in the universe. Supernovas and black holes and whatnot have been kind of detonating for billions of years. And Earth and the moon have been hit by these particles. And we're still here.
Mm.
It can't be that dangerous. This is a fairly good argument, but you can quibble with it. I have some papers where I'm kind of analyzing it, and it turns out to be complications. I'm convinced that particle accelerators are safe, but you actually need to work rather hard on proving it, which
Mm.
is, of course, super annoying if you're a physicist and can't wait to turn it on and find the Higgs boson.
Mm. Wow. Um. What
So
about
related to this is strangelets
right?
and other things like little black holes. Basically, it's the same idea. If you get enough energy together, you can make weird forms of matter that turn normal matter into itself, and
Mm.
then Earth might implode into a ball of strangelet, or we might get a little black hole. And
Mm.
again, it turns out that it's probably not a risk. We have good reasons, given the amount of supernovas and other weird stuff we see in the sky, to say that, yeah, this doesn't happen very often. So the accelerator looks very safe. But
Mm.
again, the physicists are good at making up scary stories for us.
Yeah. What What about some of our technology that can be that can be a disaster? Like Eric Drexler. Shout outs to Eric Drexler. Thank you for introducing me to Dr. Anders Sandberg. Um, what about the gray goo that he talks about that he came up with? The famous gray goo.
Oh, yeah.
Mhm.
Yeah, he really, really hates the Grey Goo because in his classic book, Engines of Creation, which is amazingly good,
Yeah, I have
that was
it.
one of the books I read that made me a transhumanist.
Yeah.
He points out that, well, you could make nanomachines that make other nanomachines, and maybe we could lose control and get this Grey Goo that eats everything. In the next paragraph, he points out that this is probably not a problem and gives good reasons why it's pretty safe and you can easily design around it.
Right.
However, it was a cool term. So throughout the 90s, people started talking about gray goo and got worried about nanotechnology because of gray goo, despite Eric showing that this doesn't work that well. And there are
Right.
way better ways of making nanomachines. And if you can make a gray goo nanomachine, you can make other super scary things anyway. You would probably not even bother with the gray goo.
Mm.
So the problem here is that nanomachines needs to be designed to work in the normal environment in order to act as grey goo. But there is a kind of self-replicating machines that already exist, and they're called living cells. Bacteria and plants, and well, to some extent humans, are a kind of green goo. And biotechnology has this interesting problem that you might want to use your cells that you culture in a test tube to make some chemicals or study something, but they want to replicate. So keeping them under control is something that biosafety people need to work a fair bit at. Meanwhile, our machines normally don't want to replicate, except, of course, that people write computer viruses and worms and malware. So we already have this problem online.
Right.
Now, the scary thing is once you get self-replication of any kind, it tends to grow exponentially until it runs out of stuff to replicate in. And this is true whether it's bacteria growing in your fridge because you've forgotten a dish for too long, or whether it's computer viruses hacking computers. Eventually it runs out, but before that you get this exponential growth. And if it's fast enough, it's very hard to respond fast enough. So in the 90s, people were starting to joke about a Warhol worm. So Andy Warhol said that everybody's going to be famous for 15 minutes in the future. And the Warhol worm would be a computer program that infected every computer it could reach in 15 minutes. That has happened now. There was actually a little worm program that managed to spread globally. It didn't affect all computers, but all the computers it could infect, it did get in about 10 minutes.
It was a cyber attack, or just
It
something that.
was kind of a cyber attack. It was probably somebody else that wanted to see, could I make something that replicates really well?
Yeah.
So the weird thing is cyber attacks, that's somebody who wants to do something. Maybe I don't like a certain company, so I try to hack the computer or sabotage for them. But then you have the people who just think that, oh, I want to create life. It would be so cool to make a program that spread. This is actually how the Morris worm, the first really big outbreak happened. So Morris basically wanted to just have a little program spreading across computers on the network and giving him a map of it. But then he wrote it in the wrong way. So it was spreading too fast. It took all the system resources and computers started crashing. This was back in the very early days of the internet, back in the 80s. So the number of computers on the internet was a few thousand at most. But it was a big problem. And of course, Morris ended up in a great deal of trouble for that.
Wow. Wow. Let me see. What about well, you said solar flares. We went through solar flares. What are we doing about nuclear disarmament? Like, what is the scientists?
Yeah.
I think this is a worldwide problem, and scientists all around the world, and just everybody who needs to get behind the worldwide scientists to push for nuclear disarmament. I think it's really a bad problem. And where are they stocking all this when they're not in use? Like, where does it go? Like, it's probably a great waste. Say creating by creating this.
It's an enormous waste because it costs quite a lot to maintain the nuclear arsenals. And it's a very scary problem because the nuclear arsenals also, many of them are on a fairly high alert. And it doesn't take much to imagine a computer error or a slightly confused president or just a diplomatic situation getting out of hand to cause things to become very dangerous. So I remember this was probably my first taste of existential risk as a kid. I was growing up in the 80s, and I remember the pop songs on the radio, many of them were about nuclear war. It was in the newspaper. I remember lying in bed thinking the missiles might be in the air tonight.
Yeah.
And indeed, that was not wrong. When we opened the archives from the Cold War in the 90s, it turned out that there was quite a lot of close calls.
Yeah.
The most famous one was in 1983 when Stanislav Petrov was manning this station under Moscow, watching satellite feeds. And suddenly all the computers started blaring and saying, it looks like Americans have launched a preemptive nuclear attack. And his job was basically to check that the computers were working right, and then the phone and kind of call the higher ups and tell them what was going on. And given the tensions at the time, this was a very tense moment. They would no doubt have pressed the button. except that Petrov felt, I don't trust this. This doesn't make sense to me.
Mm.
So he delayed, and after 15 minutes, yes, it was a computer error. He
Wow.
saved the world. Yeah,
Wow. Much
he was
respect
an
to him.
amazing hero.
Wow.
Unfortunately, it wasn't good for his career because he disobeyed the orders. He didn't follow procedure, but he saved the world.
I think I remember this because Gorbachev was in office, and I remember doing drills. And I think Gorbachev was in office in Russia at that time, if I'm not mistaken. What
This was before Gorbachev.
this was
This
right
was
before?
when the Cold War was at its coldest, and there were
Oh, okay.
several incidents like that. Ronald Reagan, for example, he did a military exercise in Germany called Able Archer. I think
Mm,
this might have been 83 or 84. And he was mostly doing that to show off,
mm,
except that the Soviet Union was convinced that this crazy Christian fundamentalist president is probably planning to invade. So they were kind of sitting there waiting to press the button at any sign that something was happening. And they're getting more and more convinced that, oh, yes, this looks all like our scenarios. This is going to end very badly. And then, fortunately, they got distracted because the party chairman got a kidney problem, and suddenly a lot of politics happened and the exercise ended. The interesting story there is that a few months later, the intelligence services told Reagan about it, and he was horrified.
wow.
He realized, oh, I was this close to causing a nuclear disaster. So that's why he later on, together with Gorbachev, started on with nuclear disarmament. The interesting thing here is that this is an area where maybe scientists, even hard sciences, have less useful things to tell you than the soft sciences, as you say, the sociologists, the diplomats, the political scientists. We need to figure out nice ways of doing disarmament that keeps everybody feeling safe, that saves everybody face and so on. And unfortunately, the
Wow.
world right now is kind of going in the wrong direction.
Right.
Most recently, my current adoptive homeland, the United Kingdom, has decided let's have a few extra missiles. I
More
think
missiles.
that's probably a little bit like somebody after a divorce getting a much fancier sports car. I think it's kind of UK trying to look a bit cooler than it is after Brexit, which is a very bad idea to get nuclear weapons.
Wow. I'm old enough to remember, when in elementary school as a child, I think 8 and 9 years old, doing nuclear drills, like having to go underneath the desk. I mean, I can still remember that. I know the kids today don't remember going through these drills in elementary school, but it's not a good thing. It's really terrible to put kids through this, no matter what country you in. No kid should be preparing for a nuclear disaster. We have to do more.
Yeah,
Yeah, we have to do more.
we definitely have to do more.
Yeah.
So there was this resolution by the United Nations a bit recently to kind of try to ban nuclear weapons, which is
Mm-hmm.
mostly a diplomatic gesture because none of the countries that have nuclear weapons ever signed up for that.
Right.
But there is an interesting thing. It's the work on actually saying nuclear weapons are immoral and bad things to have. Yeah, maybe it's legal for you to have it, but you're a bad nation for having them.
Mm-hmm.
It might be that we just want to build up this as a consensus, even though it might be hard to use that directly to force nations. It might also be that we need to come up with better ways of creating other safeguards. Europe, for all its faults in the European Union, by tying everybody together economically, that means that it's very unlikely that you will ever get a war on mainland Europe ever again. In the past, of course, Germany and France were always at each other's throats, but now their economies are so interlinked that the sheer bureaucracy of having a war makes everyone say, no, we're not going to do that. We're going to have a quarrel on Twitter instead.
Right. 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 Wow. Well, what about uh, mm, what about the a hostile, unfriendly artificial intelligence? Like when we, I'm hearing all this talk, about if in the future that we could possibly have we could create an unfriendly AI somewhere. Like, what's the possibility of that happening?
This is something that is keeping us rather busy at the Institute. Right now, the risk from artificial intelligence is essentially zero.
Right.
And the idea is let's keep it that way. Because artificial intelligence is getting better and better. You can do a lot of cool stuff with it already, and it's going to get exponentially better in the future. The problem is, of course, if you can do very cool, very powerful stuff with any technology, then you can use it to destroy.
Mm-hmm.
Or you can just accidentally let it loose and get trouble. Remember those examples with computer worms. Some of them were not intended to do any harm, but they certainly caused a lot of damage. And
Right.
indeed, there are experiments on using artificial intelligence to automatically figure out how to hack other computers. Again, the people involved say this is for defensive purposes. We want to use this to figure out how to protect ourselves against being hacked. But you can totally imagine others saying, yeah, I'm totally
Mm-hmm.
going to use this in an aggressive way. That's even without the software itself wanting to do anything. It's just that people might use it and amplify their own powers. But the real scary thing is, of course, as the software gets smarter, it might behave in very unexpected ways. So normally when you talk about unfriendly superintelligence, you imagine Skynet and Terminators. And in most movies, the unfriendly AI is kind of like a human on a bad day.
Right.
It hates people, it wants to do certain things for certain reason, but it's still doing it for a comprehensible reason.
Mm-hmm.
But if you think about how software just malfunctions in really weird ways, you might instead have something that's super intelligent and start doing something that is incomprehensibly weird and very bad for us. And it's going about it in a very clever way, so it's very hard to stop.
Mm-hmm.
So the classic image people bring up is the paperclip maximizer. I tell my super intelligent AI, make me a lot of paperclips, and it interprets that as make as many paperclips as possible. And
Mm-hmm.
it figures out a way of turning the world into paperclips. Being super intelligent, it figures out humans are not going to like this. This is how I take out the humans so they don't stop me from making paperclips.
Mm-hmm.
Now, many people will say, yeah, that sounds a bit crazy, but nobody would be crazy enough to give that command, which I think is totally wrong because people do stupid things all the time.
That's right.
And yet, more plausible scenarios when you imagine a company saying to its AI, well, make our stock value go up as much as possible.
Mm-hmm.
So the AI starts giving really good advice. And it only wants to help the company do well, make a lot of profit, and run well on the stock market. So it might give a very good advice. And of course, any executive that doesn't follow the advice makes the stock value go down. So it also advises against keeping those executives. So they get fired.
Mm-hmm.
And now you have a loyal company that is maximizing its stock value. And well, ethics and morality and the environment, that wasn't part of the command here. It's just maximizing the stock value. And other companies need to have similar AIs to compete. So now all these AIs, they also realize, if Congress passes laws against us, that's going to be bad for the growth of stock value. So we need to lobby together against those laws. So
Mm-hmm.
then you end up with a world essentially run by companies that try to maximize numbers. They don't care about the environment, they don't care about the employees, they don't care about anything except maximizing these numbers because that's their job. That's also a disaster. And there are probably much stranger disasters that are possible to happen. So the question is, can you construct a friendly AI that is something that is aligned with human values and interests? Something that understands that Anders probably want a pile of paperclips, not the world turned into paperclips.
Right.
And you might imagine an advisor AI that asks the CEO, should I care about the environment?
Mm-hmm.
At least if it asks, that's kind of useful. You might want to have a superintendent that actually reads the library and realizes you must care about a lot of stuff they haven't asked me about. Maybe I should ask them about it, or maybe I should just figure out for myself what they really want because they seem to be pretty bad at explaining it.
Mm. Yeah, because in the news you hear about Elon Musk creating the Neuralink, and you heard the late Stephen Hawkins talk about the problem with AI, and we need to do something about that. And do you believe that AI will become more? You hear Ray Kurzweil speak about this a lot too. that AI will become
So Ray Kurzweil, it's really optimistic.
yeah,
He thinks that, they're going to be like us. And
right.
if there is any risk, teach them the golden rule and then everything is fine. And while I love that optimism, I think it's kind of unsafe to base your technology safety on that optimism.
Mm,
So Musk, on the other hand, he has this idea that Neuralink, by getting neural implants, maybe we can either enhance ourselves so we're smarter than the AI. I
right.
think that's going to be tricky. Or if you can't beat them, join them. So now we're linked to the artificial intelligence. And I think there is a chance of actually getting our values into the machine this way. If I'm connected to a robot and the robot wonders, should I help the little old lady across the street or
Mm,
push her? Uh, then it can look into my brain and notice that Anders really strongly approves of helping little old ladies across streets. But he really doesn't like when I push them in front of cars. Aha, I know roughly what I should be doing. And maybe an even better neural interface will give good reasons. Oh, something called compassion.
mm,
Okay, that might be a reason that I should try to learn more about. Now, the problem here is, of course, people love to hype things. So we're both hyping right now artificial intelligence for being amazing, and it's
mm,
advancing really fast. But in the past, we also have had long stretches where there was no progress at all. So it might turn out that we're going to get an AI bust the next 10 years. But
mm,
in the really long run, we are probably going to have to share the planet with artificial intelligences that can be really weird. And we need to figure out a way of getting along with them and getting our human values across, which is tricky because human values are complicated things.
mm. So this idea that artificial intelligence will achieve intelligence more than a human being is that a possibility?
I think so. I don't think
Mm,
there's anything special about our brains that make them kind of the smartest object possible in the universe.
mm,
They're pretty nifty, but they could be bigger. They could be faster.
right.
As anybody who forgotten stuff or gotten just confused by reading a paper realizes, if I were only a little bit smarter.
Mm,
Now,
yeah.
artificial intelligence might also think in very, very different ways, which is sometimes great for solving problems that humans can't handle, but they might be baffled by things that is everyday for us.
Right.
It's kind of telling that we're good at making chess programs that can beat a grandmaster, but it's still very hard to make a robot that can brew a cup of tea.
Oh, okay. Yeah. It's narrow. Okay. Well,
Yeah, so that is the problem. Many of our systems are very narrow.
yeah.
They only do one thing, and they might do that well. Making a general intelligence is tricky because we don't fully understand the intelligence itself.
Mm,
But intelligence and morality are also different things. So you want to, at the point where you get the super intelligence, also have a super morality that you want to put into it.
mm, yeah, I agree. Um, what about I was seeing, you know what? I seen something that what is it a possibility we can go through another famine?
Another famine.
Like a bad, really bad. We can go through a really bad worldwide famine.
I think it's tricky, but it's not entirely ruled out. So
Mm,
the problem here is we're dependent on a few really big crops for most of our food:
mm,
rice, wheat, soy. The list, if you look at Wikipedia, you will find kind of at the top five crops. They're responsible for more than half of all the calories we get.
mm,
Now, the problem is many of these crops are cultured as monoculture. If you go to the Midwest, you find these endless soybean fields that are
yeah,
amazingly productive,
mm,
turning sunlight into food. Whoa, you can actually see it on satellite maps how they deplete carbon dioxide. They just gobble up all the carbon from the atmosphere to turn it into more soy. Great, except of
mm,
course that many of them are so genetically similar that you could imagine some little bug that start affecting them, and then we might lose an important part of our crops. Even worse, you can imagine bioterrorists or
mm,
military people saying, if we want to strike at our enemies, what if we make the crops fail? And
right.
then, of course, things get out of hand. Or you could indeed have something like the supervolcanic eruption. And of course, what's also at the top of many people's mind is climate change.
I was going.
Many
Yeah.
crops are pretty optimized for certain climates. So if things get hotter or drier, they might no longer work in the same places. I think this is generally not a big problem because you would just plant them further north. You would shift things around,
Right.
except that you can get a surprise. And sometimes the surprises are not even because of climate. So a few years back, there was this spike in fuel prices because of various speculations and some political events in the Middle East.
Mm.
Now, since a lot of soybeans are being used to make ethanol for biofuel, and the fuel prices went up, suddenly a lot of soy got turned into fuel.
Mm.
That meant that a lot of the prices for food also went up, partially
Mm.
because also you need fuel to run your tractor. Suddenly, a lot of poor people in various parts of the world got hungry. And
Mm.
this might, according to some, have triggered a bit of the Arab Spring because part of this fluctuation, which was just due to a bundle of different reasons, caused not so much a famine, but trouble. Now,
Mm.
you could imagine this on a bigger scale. So, you could imagine a world that is already stressed by a lot of climate change and maybe other political things. And then one day you have maybe an outbreak of something affecting one crop, and the other crop is failing because it was a bad year. At that point, I don't think the world will starve, but you
Mm.
get a lot of angry and hungry people. And that's kind of scary in a world with nuclear weapons and maybe automated drones, etc. So we
Mm.
want to guard against this kind of systemic risk. But notice how it's so different from those lovely asteroids. An
Mm.
asteroid you can kind of push away so it doesn't impact Earth. It's a very solid thing. It follows the laws of mechanics. What do you do about the global economic system? What do you do about the trade system? Whoa, suddenly you need experts of all kinds. And it's a lot of politics and a lot of very tricky things that we need to resolve. This is the toughest kind of risk.
Mm.
Even getting to safe artificial and superintelligence, in some sense, is a simpler job because we can at least program it from scratch. We can kind of solve mathematics and game theory about how to make something nice. It's very hard, but it's a concrete problem. How you update the world economy? Oh dear,
Oh,
it got 7.3 billion people in it.
right, right. That's a little bit more complex. Yeah, I see what you're saying. Wow. What so? What do you think is the top accidental risk that everyone should know? Our future hip hoppers should know about, like the top ones that you guys are really seriously concerned about.
So right now, nuclear war is still on the top of the list, which is kind of an oldie but a goodie, or a baddie, maybe, as the case might be. And it's interesting for us who are old enough to remember the Cold War, how people forgot about it in the 90s. In 1990, the Berlin Wall came down, everybody were hopeful and happy, and we all forgot about the missiles in the silos.
Mm.
It actually took North Korea and to some extent Donald Trump to make us realize, oh, they're still there. They're
Right.
still as horrifying as ever. Um,
Wow.
and this is a risk we need to deal with. And it's a political risk, and it's a tricky one. In second place, I have my worries about bioweapons and biosecurity. We have
Mm.
seen how much of a mess a pandemic could be.
Mm.
And we have been lucky with COVID-19 because if it was like its cousin, the SARS virus, then there would have been 100 times as many dead people. That's kind of a horrifying thought.
Yeah.
And SARS is still not as deadly as some other diseases that we know. And you can totally imagine some mad genius saying, oh, I could probably beat that. Ebola, that's just the starter. We're
Wow.
getting more and more powerful biotechnology. And this is both good news and bad news. The bad news is we can design horrifying pathogens, but we can, of course, design better solutions. When it came to COVID,
Mm.
well, people were coming up with vaccines almost instantly. Then it takes a long while to test them to see that we're safe enough that we can dare take them. But we're getting faster at that. There are forms of pathogen surveillance where we try to figure
Mm.
out what's those new bugs moving around. And maybe one day we can just have a little device in our smartphone that bleeps and says, there is a bit of anthrax in that room. Maybe you want to leave. Um,
Mm.
but just automatically sequences weird stuff it encounters. It might be that we can construct a global immune system that protects us all, both against natural and artificial diseases. Uh, but I think the really tricky risks are the ones that are complex. And they are the ones where the natural sciences might not have as much useful things to do as hip hoppers can, because they're about humans. They're about the weave of our societies and how our economy works. They're about how we relate to each other and understand the world. This is way too complex to just handle with standard science. I can write down some nice equations, but that's not going to fix the problem.
I see your point. Um, wow. You heard of the Doomsday? I know you know about the Doomsday clock, right? Is that a real thing? The Doomsday
Yeah,
clock?
so it's mostly symbolic. So, Bulletin of Atomic Scientists was founded after the Second World War by some of the people who had been involved in the Manhattan Project and built the atomic bomb. And now they were kind of horrified at what it was going to be used for.
Right.
So, famously, on the cover of this journal, they have this stylized clock showing how many minutes to midnight there is. And over the years, they have been moving this to indicate kind of how scared they are about the world. The problem is, of course, you can there is a limit on how close you can move it to midnight and still retain credibility. So they have been kind of moving it a few seconds back and forth. That doesn't really mean very much, but
Right.
it's kind of a symbol of how concerned we are.
Mm,
The actual probabilities of nuclear war or the actual probability of the world ending in one way or another, they're trickier to calculate. And I think they're relatively small, but it's a bit like Russian roulette.
mm,
Okay, one chance in six that you get killed. Ooh, that's still way too much. So I think maybe there is kind of about one chance in 10 that we
mm,
end badly this century. I'm
mm.
an optimist. I say, oh, 90% chance that we'll muddle through.
Yeah.
But most people say, wait a minute, that's super scary.
Yeah. Yeah.
And then my response is, yep, let's make it less scary. Let's fix things.
Yeah, I agree. Um, what is UG99? That's what I was talking about. What I was thinking about when I was reading. It was something about UG99 about. They were talking about crops and stuff. It's like a something that could get into the crops. It was like a it's some type of bacteria, right? UG99. Am I
Yeah,
right about that?
because the problem is that if you culture all the same crops, it's
Mm,
vulnerable to the same diseases. This is why we might lose bananas, for example. It turns out that practically all the bananas sold in supermarkets are the same kind, the Cavendish banana. And there is apparently some fungus that likes this one. So it might wipe out that variety.
mm,
Turns out that there was another variety before that that got wiped out. So we are not even having banana classic flavor. Now, there is a lot of other bananas and plantains that actually are grown in the tropics. So we're probably going to be able to get new kinds of bananas if we lose this one. But it feels like we ought to be doing better. We need more variety. Diversity is really a powerful tool, actually. We
mm,
need it in our computer systems. If some little virus that loves Windows computers, the Apple owners are going to be laughing. And
mm,
if they are having a trouble, the Linux users are going to be happy. And so, similarly, we want our immune systems to be very diverse and varied. Maybe I'm very vulnerable to COVID, but you're not.
right.
It's a great thing to have a diversity of people. And we want to have the same thing, a diversity maybe of economies, a diversity of crop plants, maybe
Mm,
even a diversity of artificial intelligence that can keep each other in check.
wow. Um. Wow. What about overpopulation? Because the Earth does have a carrying capacity, right? Yeah.
Yeah, but the tricky thing is in ecology, we talk about a carrying capacity for a species. And you can even define it if you think about rabbits on an island, there is only so much grass and herbs for them to eat. And beyond that, they're going to starve. But rabbits don't farm. If rabbits started farming the island, of course, they could make way more carrots than would normally grow, and the carrying capacity would increase. So talking about human carrying capacity is tricky because we can change it using technology. This is what we have done using agriculture. And as agriculture gets better, you can feed more people. There are other problems, of course, of having a lot of people because we get cities and roads that cover a lot of ecosystem. We might be trampling a lot of nature just because there's so many of us. Uh, but the carrying capacity, although it's finite, we can kind of push it.
Mm.
Exactly, push it is an interesting question. I'm fairly convinced that you can go up to about 1 trillion people. At that point, there is not much nature left. Everything is kind of a park or agricultural city. But yeah, you can totally have that many people. It's just that maybe we don't really need have trillions and trillions of people.
Mm.
Uh, the laws of physics basically allow you to have an enormous number of people, but a lot of it depends on what kind of societies we want to have. So the big discussion about overpopulation came about in the 60s when indeed the global population was increasing at its fastest. And it was a weird combination because you both had people having honest environmental considerations. Many were worried about poverty. There were also a bit of a kind of shady racist ideas about it was the wrong people that were increasing the most.
Right.
So you got this mix of motives, and some of them more than a little bit scary.
Mm.
What then happened was the growth rate started leveling off. Certainly, there are more and more people, but we're not having as many kids anymore. And this is a fairly global phenomenon. And part of the reason was female education. Part of it was rising prosperity. If you're living in a better life, having a lot of kids is less necessary for guaranteeing that you get a good retirement.
Right.
So gradually, we have entered a situation where some regions might actually having the opposite problem. There are too few kids. And when there are few kids, you're going to get less schools and less playground, and fewer of your friends are going to have kids. So you might not think of getting kids. So you might have population that go down, which is also bad for both culture and economics. So
Mm.
handling a population is tricky, and we're bad at it. We don't even fully understand what's going on.
Mm.
But this is where I think, for example, improving longevity might be quite useful. If there are fewer kids around, well, maybe we can stay around for a longer time.
Right.
I think that could also help stabilize populations a bit.
Mm. Wow. That's
Yeah, it's an interesting world we're living in.
wow. Yeah, we touched on a lot of stuff. I'm glad. So I'm gonna look. I'm gonna listen to
Yeah.
this as soon as we done. Um, who are the Bulletin of the Atomic Scientists? Did I say that right? The Bulletin of
So
Atomic
this
Science.
is this journal, originally mostly about nuclear disarmament,
Mm-hmm.
and it had this heft because the founders were actual nuclear scientists who were worried about the nuclear weapons. And
Mm-hmm.
over the years, it's been publishing a lot of things about concerns, whether that's overpopulation or pollution or other threats. The idea of existential risk is a relatively new one, actually, but they were certainly thinking about the big, weighty threats to the well being of humanity. And they have been doing that for a long time. So it's kind of a classic place to talk about these things.
Mm.
I'm proud to have the one article a few years back in there
Oh wow.
about existential risk. But yeah, there is a lot of stuff that worth reading.
Wow. Wow. Is our water supply in danger?
Yes and
On the planet?
no. So it depends a bit on where you are in the world. For example, in many places of the world, we're of course pumping out way more water from the aquifers than it's getting replenished from the rain.
Mm-hmm.
And this is going to be a big agricultural problem. I am worried about the southern part of America, Midwest, because those big aquifers are getting depleted at an astonishing rate. And there are many other parts of the world that are also doing this very rapidly.
Wow.
Then there are other parts that are also dependent on glaciers that might be melting away because of climate change. So, for example, North India, which gets a lot of water from the Himalayas, they might have a real problem here.
Mm-hmm.
On the other hand, when I go up to the north of Sweden, it's easy to feel smug because, yeah, here you get winds blowing in from the Atlantic and raining mostly on the Norwegians, but a little bit on this side. So some
Mm.
regions are doing totally fine.
Wow.
I think we need to work more on better desalination. In some
Mm.
sense, desalination is a form of mining. It's just that the thing you're trying to mine here is water instead of some metal. And the ore you're mining from is seawater. It takes a lot of energy. But then again, we're getting better and better at solar power. And it might also be that using nanotechnology, you can make better filters to automatically get the water through. Now, the problem turns out to be gunk, organic gunk, dirt, and the other stuff that covers these filters. If we just had a really good trick to get rid of that, desalination would be much better.
Mm,
And I think that way you can also purify water,
mm,
because it's not just a question about getting rid of salt. You might want to get rid of bacteria or other contaminants. In parts of Bangladesh, for example, there is quite a lot of arsenic in the water. It's
mm.
natural, but it's really bad for you.
Right.
So you want to come up with a good way of binding that. And to do that, we might want to use biotechnology or nanotechnology to come up with these filters that have microscopic pores that let through only water.
Wow, I'm glad you mentioned that. That's a positive aspect of the technology that we can use to improve the environment. Thank you for that. Um,
I
what else
think
do you?
there's so much we can do. Nanotechnology and biotechnology and artificial intelligence, they might have dangers, but they're also wonderful tools for making the world way better.
Yeah,
I
yeah.
mean, sustainable energy. You want nanotechnology to make solar panels super cheap, and you want nanotechnology to bind carbon dioxide to get rid of the climate change. Biotechnology, brilliant for making various green solutions to things, or plants that produce the chemicals we need instead of having to use factories for it.
Yeah, renewable energy. Yeah, yeah, yeah. Geothermal energy is pretty good, right? Geothermal energy
Yeah,
to cool and
I
heat
used to
things.
be slightly down on it, saying, yeah, it's great if you're on Iceland and in some other places, but in most places of the world, well, the crust is thick and you don't get that much heat. But here
Mm,
is a fun thing: the fracking industry has actually come in and helped us here. Uh,
mm.
that's kind of weird, and they probably don't appreciate creating
Yeah,
a competition.
yeah.
But basically, what you do when you do fracking for oil is
Mm,
that you drill down deep and then you crack the rocks down there so you can see suck up the oil.
mm,
Now that is also really good for making geothermal work. So
mm,
you drill down much deeper than normally you would do, and this again takes a special kind of drill with a diamond tip that was developed for the oil industry. But now we can go way deeper than people used to think was possible. Then you crack the rocks, and then you can do geothermal that apparently has much more potential, even in places where it used to be that, yeah, you can't get any geothermal energy here.
mm.
So I'm kind of having to revise my views there. Very happy to have been wrong about it.
Wow. Um, is there anything else you would like to say to my audience before we head out? This was very interesting. I would like to have you back on. I could talk to you for another
Yeah, I'm
hour.
happy to
I
do
know it's
that.
late. I know
There's
it's
so
late in Stockholm.
much to talk about.
Yeah, this is a bit. This we have to do this again because, um,
Yeah,
yeah, there's so much to talk about on this topic. And all my hip hoppers listening, we're giving you a lot of material to rap about. Do not be afraid to sound intelligent and do not dumb yourself down. We're not doing that anymore. We're gonna go into another age of hip hop. We're gonna go into. I'm gonna bring. We're gonna bring a transhumanist, futurist age in the culture of hip hop, where we don't dumb down our lyrics to sell to the greatest possible people you can think that you can. We're not doing that no more. I want to give a very warm welcome. Thank you to Dr. Anders Sandberg to come here to the institute to take time his busy schedule to talk to us because I know he's very busy. He's writing articles. He's working to save the planet. I want to give him a warm thank you. Thank you, Dr. Anders Sandberg. I really appreciate this.
and thank you for the delightful questions. And
Thank you.
let's see how smart we can make the world.
Yes, yes, and I think I got a little smarter just talking to you, just talking to you today. Thank you, man. um, I'm Lord Maitreya.
Thank you.
This is Dr. Anders Sandberg. We definitely gonna have him back on. We out. One love, everybody. Let's save the planet.
Yeah, let's save the planet.